Hello everyone, welcome to lecture number 12 of Applied IoT. Here we will try to complete and finish everything on the main topics of Applied IoT, right? Before going into it will be a little bit longer lesson, so that I will not go through the earliest subject matter we talk about. Traditionally we talk about what we have learned so far, right? We go through what is IoT devices, right? We go through applied IoT, right? We talked about M2M, right? How that is now evolved with IoT. We will talk about OT, IIoT, and so on and so forth. We looked at the market perspective, and then we came into the value chain, right? The whole value chain lies on the architecture, right? Building a IoT system would include perception layer, transport layer, processing layer, and applied layer. In between, the collection of these four layers will create entire IoT system, right? Which will solve a problem, improve decision making, automation, so on and so forth, right? Um, so IoT system would include these four layers, which is we will generally say the architecture overview, right? And by building these four layers, we build a IoT system. IoT system consists of will create value, right? That IoT system will create value by solving a problem, automation, or by improving the process, right? Making, helping decision making, so on and so forth. It will add value, right? That value is defined, or that value is shown by the IoT value chain, right? IoT system would have a IoT value chain. The IoT value chain will be catering to, or will have components of these four layers. We talked about all these things. I think you understand when there's a IoT system implemented, there will be value creation. So that means there will be a IoT value chain in that system, right? Then when we talk about all those points, right? We have to talk about what will be there on what are the main design principles and its capabilities of a IoT system. Basically, what we are talking here is what are the common properties that we can see in these four layers. Now, before starting the lecture, right, I want to let you know why are we learning these things. Why that would be the main problem, right? We are not learning anything about coding. We are not learning anything about building a IoT device. So in applied IoT, why are we learning this, right? So I will take some time just to explain that part, so that I think that question will be fulfilled, right? In the world of engineering, right, if you take the value chain, when you go into this industry, if you step into this industry, you will be positioned somewhere in that value chain. You will be an engineer who will be manufacturing devices in the R&D section. You will be a project manager who will be handling a IoT project, where it could be implementation, or you will be a service manager who will be maintaining a IoT system, or you will be operational manager who will be also will be there for maintaining or manufacturing devices, maintaining the network, so on and so forth. You will be a product owner for the customer side, who will look into the properties and the values of the IoT system that you are going to buy. How it's going to create value? Does it fulfill all the requirements, right? Or you will be a IoT systems architect who will design an entire system from top to bottom, including these 4 layers. Or you will be an entrepreneur who will start your own business, a startup which will provide IoT services, or which will manufacture IoT devices, so on and so forth, giving IoT solutions. Whatever that situation is, right, you will be giving a IoT product, right? In the value chain, you have IoT devices, you have network, you have processing power, storage, and so on. So you have the cloud, you have the application, you have the service management, and you have the customer. Wherever you place in that, you place yourself in that value chain, right, you will be interacting with the IoT system. You should know, does all the 4 layers cover the IoT system, right? You should understand the IoT system by understanding the 4 layers. After understanding the 4 layers, you should see all these 9 points, including stability, interoperability, security, reliability, data management, privacy, energy efficiency, real-time and low latency, and user-centric design. You have to see that all these things are also fulfilled depending on your requirement, depending on the customer requirement, right? And if you are on the customer side, you have to see the product that they are selling to you fulfills those requirements as well, right? Not only resolving your problem, while resolving your problem, these qualities must be there. Otherwise, the value of the IoT system will go down. When the value of that IoT system goes down, right, there will be a level where the value produced from the IoT system is less than the value spent by the customer to maintain in that IoT system. When that is the case, the entire IoT value chain breaks down, right? So that is why we have to learn, or we have to have an idea about the entire IoT infrastructure, or the entire IoT system, so that you can apply each and every point depending on your job role inside the value chain, right? We don't look at technical things, we are looking at what are the things that is needed to be covered. Because if you are to be an engineer, right, you cannot be a back-end engineer, a front-end engineer, UX engineer, perception layer engineer, software engineer, network engineer, R&D or service management at the same time, right? You will be placed inside the value chain at a specific location, but you should have the ability to understand the entire value chain and the entire IoT system, so you can design a IoT product, or give IoT service, or carry out your job as a project manager, as a service owner, right? You can carry out your responsibilities properly by knowing these main design principles, right? After these points, right, anything you have to learn about applied IoT are subsections or deep dives into these 9 points. So these 9 points are important, right? The architecture, the architecture of a IoT system is important. The value chain is important to know. What is applied IoT is important to know, and what is information or understanding about the perception layer itself or the IoT devices is important to know when coming into applied IoT, right? In lecture number 7, that's why I went off the subject lines and just gave you examples, visual examples of how IoT is applied, so you will have an idea on how in the real world this IoT is being used, right? What is IoT ecosystem and so on and so forth. Then by knowing that, if somebody says I'm going to build a 50-story building, can you please help me to design in a design a IoT solution or design a smart building, right? Can you handle the IoT side, from access control to fire control, to security systems, right? Checking your elevators, your networking inside the building. There could be plenty of things that will be there will be a speaker system inside the building. There will be checking the air purity, the temperature inside the building in respect to the outside of the building, the heating systems or the air conditioning systems, right? There will be a central control panel that can handle all these things. So IoT system have to have all those things, right? And on top of that, it should have the ability to, okay, now the building is going to have a new attachment, right? A second building is going to build on the other side, but it is going to be the same company. So that means the IoT system in one building should be replicated on the other. 100% growth in the system, right? On the IoT system. So scalability is important, right? If the customer says we are not satisfied with the temperature control, we have to change the temperature control units, right? You go through, you study, you check what are better units. Interoperability is important when changing sensors, so on and so forth, right? So I think now you have an understanding of why we are learning applied IoT, right? Okay, now we can go back to the lesson and finish this section. Secure over-the-air updates. IoT devices often require firmware updates to patch security vulnerabilities or add new features. Over-the-air OTA updates mechanisms should be designed with security measures in place, such as secure channel for updates, code signing, and integrity checks to ensure that only authorized and validated updates are installed on devices. So one of the points that we have to see here is that we know that these vulnerability updates are done on servers through SSCM portals, which gives the capability for Windows. In such a way, we have to do the same updates to our IoT devices as well. Again, the problem that I was talking about before comes into play when you have a simple IoT device which may be with one sensor to detect a single phenomena, like the temperature, right? A temperature sensor. So how does firmware updates or security updates can be sent out? So these are things that must be addressed in IoT systems. Either the pre-checks have to be done through edge computing inside the device itself, or a separate device or a server or a control center or a gateway would be there with the necessary processing power to check the firmware updates are secure and up to correct standards with code signing and everything on it. So again, when you are designing a system, as an engineer or as an IoT architect, these are some things that you have to look into. And if you are going to be a service owner for the customer, and or a product owner for the service provider, you should know these features should be there on the IoT system that either you are selling or buying. Vulnerability management. Regular vulnerability assessments and secure audits should be conducted to identify and address security weaknesses in IoT systems. Promote patching and updates should be applied to address known vulnerabilities in the devices, network infrastructure, and software components used in the IoT ecosystem. So this is something already there in ITSM or IT infrastructure management. Similarly, IT infrastructure management protocols such as ITIL or agile management systems to look into vulnerabilities and apply solutions, things like that, through where information comes through different channels from different vendors, different stakeholders, right? The similar system can be applied for IoT as well, right? Remember the very first remember the first chapters that we talked about operational technology, where IT shares boundaries, commonalities with OT, right? So that means that, right, in the IT sector where there are vulnerability management, right, OT also have similar vulnerability management. The additional vulnerability management that is needed to be done on this is basically for the perception layer, because the transport layer, processing layer, and the application layer already have those protocols in place. As the IoT engineer, it is your responsibility to see that information, the features which are already there are applied for the IoT system that you are creating. Physical security measures should be implemented to protect IoT devices from unauthorized physical access or tampering. This includes physical locks, tamper evident seals, and secure enclosures to prevent unauthorized access to device internals. Yes, so this is basically the structure of it. And now if you are thinking about IoT device which is for a smart home, you basically have to think beyond that, because again, I told you about before in the previous lecture as well, mostly these things apply for industrial applications, right? If you take Alexa as a control center, you can dismantle it like very quickly, right? Or just by using a hammer or a small knife, you can pry it open and you will have access to the hardware. But in a nuclear power plant, in a defense organization where defense manufacturing takes place, so for places like that, right, your IoT device cannot be simply made out of plastics, right? It should be some kind of a secure containment unit, right? I think you understand. And depending on the IoT application that you are catering to, security must be thought of. Then from physical security we go to privacy protection. IoT system often collect and process sensitive personal data. Privacy protection measures such as data anonymization, data minimization, and user consent management should be implemented to comply with privacy regulations and protected user privacy rights. Yes, so this is something that is needed to be think about when you are going to produce a IoT product which is for the global market, because especially in EU countries is in EU itself, right, between the EU borders, data privacy is taken very seriously, right? Anonymization is something that you can do to remove any personal data that is there when collecting data, especially if you are talking about medical data. This point comes into its own, because it is something that is very personal for a human being, and data privacy when coming into medical data is taken seriously around the world. So by only taking the information which is needed, and any personal information like location or health information or things like that from a user is being removed, right, when sending data from place to place of for different users. Privacy of a individual can be protected. Again, when designing your IoT system, depending on the requirements, you have to check these things. Security monitoring and incident response. Continuous monitoring of IoT devices, networks, and data flows help detect security incidents and anomalous behavior. Security information and event management, SIEM systems, intrusion detection systems, IDS, and anomaly detection mechanisms can be employed to monitor and identify potential security breaches. Incident response plans should be in place to handle security incidents and quickly mitigate their impact. Yes, so this is I think it is evident if you study networking and network management or network service management, right? You will have your network control centers and your SOC or security teams, right? Which also not only for network, you will have them for the entire IT infrastructure itself, right? We talked about how the 4 layers of IoT infrastructure, right? 3 of them is shared with IT infrastructure, so only the 4th layer we have to add as an additional point. But again, these concepts are already there for if you take the perception layer as laptops or smartphones, so these protocols are already there in IT infrastructure management. We have monitoring tools such as SolarWinds to see any security alerts on top of on top of those. We can build our own. If you are building IoT system, you can build your own security management or monitoring tools as well to detect any security breaches that is taking place in your system. Of course, when you are a IoT service provider, when you are uh, working on managed services chain link, right? Security incident management is one of the main things that you have to do, right? That is one of the main services that you have to provide as a IoT service provider. So from security we can go to the next topic, reliability and reliance. IoT systems should be designed to operate reliably and withstand failure. Redundancy, fault tolerance, and disaster recovery mechanisms should be incorporated to ensure continuous operations and quick recovery failures. Yes, this is also a feature that is needed to be there. Additionally, I would like to add that, right, this is not only when IoT systems are being designed, right? uh, this is a good point for you to understand that these particular points that we are talking about here is not only for IoT system, but it is for IT infrastructure. It is for any hardware. If you are into building networks, if you are into building servers, right? If you are running server centers, right? Data centers, right? Um, if you are into infrastructure itself, IT infrastructure and technological infrastructure, these properties are seen throughout, right? These are common standards for all infrastructures, right? It is not only for IoT infrastructure. Here, because of applied IoT, we are specifically thinking about IoT itself, but these are design principles and capabilities not only of IoT systems but other infrastructures as well, right? I think that's a point that I need to highlight here. Redundancy involves incorporating duplicate components, reduce or resources or systems to provide backup and failure capabilities. Redundant devices, networks, and servers can be deployed to ensure that if one component fails, another takes over seamlessly, minimizing downtime and maintaining system availability. So let me go I will go through the topics. I think these are general terminology which that I think you can understand, so therefore I'm not going to dwell time on explaining each and every one. So I'm just going to read through them because again these are normal terminology in any technological infrastructure management. Fault tolerance. IoT systems should be designed with fault tolerance in mind, allowing them to continue operation even when individual components of subsystems fail. This can be achieved through techniques such as fault tolerance algorithms, redundant data storage, and automatic error recovery mechanisms. Disaster recovery. Having a defined disaster recovery plan is essential for IoT systems to recover from major failures or catastrophic events. This involves backup and restoration strategies, data replication, and off-site storage of critical data. Regular testing and validation of disaster recovery plans ensures that it is effective and reliable communication. IoT systems heavily rely on communication networks for data transmission. Implementing robust and reliable communication protocol detection and correction mechanisms, and quality of service QoS measures ensures the integrity and reliability of data transmission even in challenging network conditions. So yes, before going into real-time monitoring, so reliability and reliance, so these four: redundancies, fault tolerance, disaster recovery, these mainly these three are addressed in data centers. Storage, if you talk about cloud services such as Azure, AWS, or Google Cloud, right? If you look into their certification courses and see the content there, if you think if you are looking into data architecture, right, in storage of data, then if you are looking into these IT infrastructure architecture as well, right, all these subjects have this with it. So redundancy, fault tolerance, and disaster recovery. So for example, disaster recovery for IoT systems would be again only for the data, right? If a fire broke out in a factory where there are IoT devices, recovering those devices will not be possible. So only the data itself is recoverable in that particular sense. Um, so mainly these redundancies and those things. So let's say, for example, if and fault tolerance, right? Of course, when IoT devices are hardware devices, depending on the location that they are being stored and kept, right, it may get damaged. It may after some time it will not function properly. So therefore there should be other IoT devices that can either take over those activities of the failing device, or quick replacements should be available. So those are some things that are unique to IoT. For example, if you have IoT devices in let's say in the mining industry, where there's a lot of dust particles which can damage hardware devices, then this redundancies, fault tolerance should be implemented in the perception layer itself. Again, reliable communication, these topics, right, QoS, and in communication, in networking, again is a part of networking in infrastructure management as well, which we are picking from there to use in IoT. So if you go to the next point, real-time monitoring, continuous monitoring of IoT devices, networks, and infrastructure allows for proactive detection of issues, performance degradation, or anomalies. Real-time monitoring systems provide insight into system health, enabling timely identification and resolution of potential problems before they escalate. So of course these are hardware devices, and in networking, if you learn about networking, if you learn about maintaining data centers and data center architectures, right, there will be software such as SolarWinds, right, and other automated softwares to check the health of those devices. If there are any hardware issues, if there are any network issues, connectivity issues, and so on and so forth, there will be alerts generated so that engineers can attend to them, either replace the damaged hardware device, or do necessary to carry out necessary troubleshooting. So therefore I think is the same the same concept should be applied for IoT infrastructure as well, right? So these real-time monitoring tools can be designed by your um, particular company which you are, if you are giving a IoT application. That application should have a control panel which would generate alerts if any hardware device is being affected by either, let's say, electricity failure, or sensors not working due to, let's say, dust or high heat, or loss of network connectivity. So there will be alerts created, and engineers can attend to them. Predictive maintenance: IoT systems can leverage sensor data and analytics to predict and prevent failure. By monitoring device conditions, collecting performance data, and applying predictive algorithms, IoT systems can predictively schedule maintenance tasks, identify potential failures, and prevent downtime. Yes. So if you remember lecture number 7, we talked about predictive maintenance. What is the predictive maintenance which is we are talking here? The predictive maintenance that we are talking here is that when you have those sensors attached to the, let's say, a motor or a generator or any mechanical device to monitor the health of that device automatically becomes an IoT device. It becomes part of the IoT system. The sensors are there to measure the health of that particular device, right? So that IoT device, let's say it's a power generator, right, to a place, and there are sensors to measure the heat of the power generator, to measure the vibrations of the power generator, so on and so forth. So suddenly the vibrations, which may not seem for the human eye, but the sensors can detect that, increase by 100%. So that means alerts will be created so that engineers can quickly attend to and see what has gone wrong before an entire shutdown would be needed, or the machine can be damaged to a point where it cannot be used anymore, right? So because the sensors are there, because it is being monitored, it is the generator becomes part of IoT itself. So this is what we were talking about, M2M, right? Machine to machine talking, in where IoT is introduced to M2M, where legacy systems are turned into IoT systems. In lecture number 7, we have a good example of that. The first example for predictive maintenance. Energy management. Many IoT devices are battery powered or operated in energy constrained environments. Implementing efficient power management techniques such as low power mode, energy harvesting, and optimization of device operations help maximize device lifespan and reliability. Yes, we talked about this, especially when we were talking about IoT dedicated networking, Zigbee, Z-Wave, things like that. The main reason we implement those networking systems is because we talked about it is mainly because preserving energy. So yes, some of these sensors are very small sensors which will be attached to different machinery or different locations with mostly battery power. So therefore power management is really important, and when talking about reliability, right, power management should be a property of a reliable IoT system. So again, not only the protocols, so we talked about only the protocols of uh, IoT networking, right? But here, of course, they are also highlighting in other techniques such as low power mode, energy harvesting, right? Optimization of devices, which also can be done through software updates, right? So more the devices are being used, we can optimize it. We know that uh, best example are electric cars. They get software updates and they will have better ranges, right? So things like that. Because how, from what? From the data which is being collected from the sensors, from the actuators, which would be the motor, so on and so forth. So part of reliability in IoT is the reliability of devices under limited power resources. Next is resilient data storage. Ensuring reliable and resilient data storage is crucial in IoT systems, distributed storage systems, data replication across multiple servers and cloud regions. The data integrity checks can and safeguard against data loss and measure data availability and consistency. So one of the main points that is needed to be checked, like what on reliance, is also the data storage. Long time ago, before cloud was there, right, we have data centers with mass storage and processing capabilities, but they were limited to individual units. So therefore, some natural disaster or hardware corruption, hardware failure, or even a fire inside the data center, right, things like that could to um, lead to data loss, right? A lightning strike can take out network connectivity, which will also reduce access to the data which we need, or to store the data we need. But all these worrisome things when coming into reliance on data is addressed on cloud. So this is why today when we talk about IoT and when we are talking about building IoT platform, for data management we talk about cloud technology. So again, if you are a service manager, if you are IoT architect, right, IoT systems architect, IoT, or if you are a startup who is trying to put your IoT device into the market, um, if having a cloud network or having in a cloud storage system to manage your data will be a very advantageous move, right? If you are a service manager or a delivery manager, it is your responsibility to show that the product that you are buying or selling in, which is in this case the IoT system, has cloud capabilities. Basically what happens in cloud capability is it provides a natural method to store data reliably, so that those reliability data storage reliability functions will be taken care of by cloud service providers, including Azure, AWS, and so on and so forth, right? Then it is system monitoring and diagnosis. I think we also talked about this before, right? To have a reliable system, you need to know what are the problems which have been occurring, right? Similar to databases, networks, right? In networks we monitor core switches, we monitor AP switches and so on and so forth, those hardware components might fail, or any cabling, fiber optic cabling between those devices might fail. When you come into a data center, any hardware component from storage to processing to power supply units could fail. So those things have to be monitored. Applications like SolarWind can be used for this, and in ITSM, where IT infrastructure management, where these things are commonly there. So if you are as I told you before, that IoT infrastructure, OT infrastructure is quite similar to IoT infrastructure management. So therefore, that the only difference in here, it would be the perception layer. So when you are developing a IoT system, you must make sure that you have the necessary application to monitor all those IoT devices, whether they are functioning correctly, if there are power outages, if there are network issues, if there are hardware failures or corruptions, things like that, right? It is are they power up, are they power off, and right, and any configuration changes that is needed to be done, updates, so on and so forth, should be done similar to similar to IT sector, right? Having things like iDRAC in Dell, or having in Azure capabilities, right? SSCM, Intune, things like that, to monitor and to update SolarWinds, so on and so forth, right? Then interoperability and compatibility. Of course, we talked about this, right? Interoperability and compatibility is also a subsection of reliability. So why this part is, I have described this part here, though we have talked about it, is because simply that all these topics are a, a, a cluster which is together. All these properties help each property to have each property properly, right? Security would help reliability. Interoperability would help reliability. Interoperability would help scalability. So each and every property would help the other property to exist in IoT system. So I'm not going to waste much time on this topics, so we can just go through the definition. Interoperability and compatibility, sorry. Interoperability and compatibility ensuring interoperability between different devices, protocols, and technologies, enhance system reliance. Compatibility across devices and systems allows for a seamless integration of new components and technologies into the existing IoT ecosystem, enabling system flexibility and adaptability. Yes, so we have covered all these things about interoperability, right? So how interoperability comes into reliability is that at end of the day, if they are not interoperable, like they cannot add new devices into your ecosystem, IoT ecosystem, right? That means a reliable it's not a reliable IoT system, right? There will be issues or errors that will be popping up. So we talked about gateways and things like that, which APIs, things which help for interoperability, which again that will help for scalability. So I'm not going to go through that again, but end of the day, if they are working properly, APIs and gateways are working properly, and we are able to take in other new devices into the IoT ecosystem or the IoT system, right, then reliability will be there naturally. So from that we can go to the next main topic, data management, right? Again, so here we are going to talk about data management. Why do we need data management in IoT? First, let's think about it. In IoT, There are in the perception layer, the main thing that would be there is sensors. Then there will be actuators. Sensors is always a thing that would input data into the IoT system. It will constantly keep adding new data, new raw data or new data points, right? Or the device can do some edge computing and input process data into the IoT system. We know that the perception layer that does not have the ability to store all that data. If you have 1000 IoT devices across let's say 3 factory buildings which are located in 2 different locations, all those data should be collected to take informative decisions about let's say the next the amount of water that is needed to be released in the next cultivation season. This is this in where this is a system where IoT is used to determine the amount of water that is needed for cultivation in each season of cultivation. So in that particular case, right, there will be let's take that example as for a difference, right? IoT in agriculture. So there will be soil moisture detectors right around the country or around that particular area, which covers acres and acres and acres. So if that will be the case, right, all this data should be stored in one particular place. So how do we know whether the soil is dry or not? We have to take data from dry soil, we have to take data from wet soil and compare them with the current values of the which are being produced by the IoT system, which would have thousands of sensors around thousands of acres of land, right? So that means that data have to be collected, stored and processed accordingly. So again, data management is very important. We today we talk about having cloud systems. We leverage cloud technology for data management in IoT. The main point that we have to understand is that we can leverage cloud technology for data management in IoT. This is very important because if you are to build your own IoT infrastructure in the past, you may have to build your own data centers and storage with enough storage to handle all the data. But today, because of the advancements and the capabilities of cloud technology, and there are APIs that support cloud technology and IoT, which supports the link between cloud technology and IoT devices. Today, cloud service providers accommodate IoT systems, right? So therefore, that data can be stored in cloud. So one of the main points that are there is that we can leverage cloud technology for our data management. Data management. IoT generates massive amount of data, and effective data management is crucial. This includes data collection, storage, processing, analytics, and retrieval. Proper data management practices should be implemented to handle the velocity and variety of IoT data. Yes, this is this is something that we talked about multiple times, that because we have a lot of devices out there, right? Because we have a lot of devices in the system itself. Normally, generally, IoT system would have a lot of devices. So because of that reason, right, because of that reason, the amount of data that is being created, especially each sensor would create its own set of data. And most of the sensors, if you think about the examples we looked at before, will be collecting data 24/7 in real time. All the time the data will be collected. If you take a small temperature sensor, the temperature sensor will be collecting data all the time if the commands were not given to collect it periodically. So data management is something that is important. Again, that is why we talk about cloud services, because when coming into data protection uh, and data storage methods, cloud services actually provide the necessary requirements, necessary properties to manage data properly. So first point would be data collection. IoT systems gather data from numerous sensors, devices, and sources. Data collection mechanisms should be designed efficiently capture data in real time. Considering factors such as data frequency, volume, and quality. This may involve employing edge computing techniques to process data at the edge of the network, reducing latency and bandwidth requirements. Yes, so this point we talked about it, right? If you think about in lecture number 7, we talked about how IoT devices can be added to legacy machines so that predictive maintenance can be carried out. So in that example, if you remember, they were talking about vibrations that may not even seen to the naked eye, but it should be monitored in real time. So that means number one, a large amount of data is going to be produced. So for that, right, to process that sensor data, or if you right, if you for example, we talked about it right here when in the processing layer, right, we talked about there will be some kind of processing that is being done on perception layer as well, which we called edge computing. So basically what is happening is, right, reducing the noise and only giving the required and proper correct data points, right? That is mostly done on edge computing. So why that is being done is to reduce the stress on the network itself, right? Another point that we talked about is, because there's going to be a large amount of devices connected to a IoT network, and all those devices will be sharing data, it is evident that we should only use the networks when it is absolutely necessary. So when we can process much of the data on the device itself, we will do that, and the necessary data will be sent to the processing layer or the cloud layer, right? We know that a reason to have in IoT, we talked about two categories of network. One is networks that are dedicated to IoT itself, right? So you can see another reason for having networking topology protocols such as Zigbee, Z-Wave, and Sigfox, things like that, is mainly to reduce the traffic in other other generally used networks, either cellular or Wi-Fi or things like that, where people need to communicate using those networks, and saturating those networks directly by IoT is not a good architectural move when designing a IoT system. Then of course we have data collection to data storage. IoT systems generate large volumes of data that needs to be stored effectively and securely. Selecting appropriate storage solutions such as databases, data lakes, or cloud storage uh, based on the specific requirement of the system is essential. Consideration include uh, da- um, Considerations include data retention policies, stability, fault tolerance, and data access patterns. So, again, yes, if you are running your own database for the IoT system, you have to think about each and every point. But if you are connecting your IoT devices to a cloud platform where cloud storage options are available for you, these criteria can be dealt with very easily. So, um, in future applications, if you are to be a IoT engineer, IoT architect, a solution provider, IoT solution provider, or a service manager or delivery manager, depending on your position, right? You will give the storage option to your customer. But end of the day, if you have a cloud storage solution, I think most of these points will be covered. And because cloud technology is being used quite generally today, it is I think we don't need to separately dive into data centers and data storage and those components of how to handle data. I think in other lessons in IoT, not only in IoT but in other subject matter, data handling takes would be taught. So the basic things that is needed to be understood is that when storage of data uh, right comes into play, especially a large amount of data which is being created by a large amount of devices or sensors, right, cloud solution is the best option. Then it would be data processing. IoT data often requires processing and transformation to extract meaningful insights. This can involve data filtering, aggregation, normalization, and enrichment. Uh, Techniques like stream processing or batch processing can be used based on the case and latency requirements. Again, yes. Um, so I'm going to just read through these points because we talked about cloud computing, we talked about processing layer, we talked about the need of real-time processing as well as batch processing of data. We took the example of our IoT weather prediction models, right? And we talked about how they need to compare the current data with old data sets to predict the weather. So in that scenario, it would be kind of batch processing, or you can say it is actually real-time processing because they need to get compare the real-time data with the old data, right? So again, and the best solution for this is cloud itself. When you have processed data, the next option would be, right, uh, of course, when you process data, your data should be displayed in a way for the human being to understand. It would be values, it would be comparisons using bar charts, flow charts, or the pie charts, or whatever the graphs, anything that can humanly recognizable, right? So your application layer is there for that. But when you process your data, right, next thing is data analytics. Analyzing IoT data enables organizations to derive valuable insights, make informed decisions, and optimize operations. Data analytic techniques include descriptive diagnostic, predictive, and prescriptive analytics. Can be applied to gain insight to patterns, trends, anomalies, and correlations within the data. Yes, we talked about uh, in early examples, right? In lecture number 7, the main reason I went off topic and showed you those examples mainly so that you will have a real world understanding of what is happening. Now you know how predictive maintenance takes place through IoT devices, and in that particular scenario, you know that, right? Though from the information that is being gathered through the IoT device, right, predictive maintenance or diagnostics of the device can be carried out in real time, and if before the before a issue takes place in the device itself, action can be taken. Another example, we talked about using artificial intelligence or same data uh, similar data models, right? Probability and statistical models to predict the best path for in logistics for let's say logistical trucks to take. How these paths are being determined because of the data which has been collected previously by IoT devices, right? We talked about those points as well, so I'm not going to again and again repeat myself, right? I think you have a clear idea about it. Next point would be data security and privacy. Again, we talked about the points of security when coming into data, right? That's why we say these things are interrelated, right? We talked about security as a property in IoT, right? When we talk about data, again we have to check the security part as well on data. IoT data often contains sensitive information. We talked about what are the sensitive information that could be collected by IoT devices, necessitating robust security and privacy measures. Data encryption, access control, and anonymization techniques can help protect data confidentiality and integrity. Compliance with data protection, regulation, and privacy guidelines is crucial, and user consent management should be implemented where applicable. Yes, we talked about this when especially coming into metadata and privacy, or let's we talked about examples of IoT devices which have been used in hospitals, so on and so forth. So yes, so we are repeating what we learned before. Why? Because each and every property that we are learning here, um, each and every capability or principles that is applied to each and every layer is the same, right? So if we are to talk about data management, we have to talk about privacy or the security in data management. If we are to talk about data management, right, data management is a quality of IoT systems. So if you are the if you are to think about data management in a IoT system, we have to think about scalability as well of that. That's why we use data lakes, things like that, options like that to facilitate large amounts of data. So please remember, each and every topic that we talk about interacts with each other. So that's why it seems that we are repeating each point again and again, right? Because when we talk about one topic, it interacts with the other topic. when we say, okay, if you take the next topic, it's about privacy, right? Privacy goes very closely with security. Privacy goes very closely with data management. So if you build a IoT device or a IoT system, or if you are an architect of IoT system, you will think about privacy, and it will come in the form of security, data privacy, so on and so forth, right? While you think about, okay, I'm going to design in a way that I can scale up this design, you will be also thinking, how can I secure this, how can I uh, uh, have user privacy while scaling up, things like that. Okay, so that's why it seems that we are repeating the topics, because it these topics interact with each other. Data integration. IoT systems often need to integrate data from various sources and systems to gain comprehensive view. So we are going to here data integration. What is the topic we already covered? Interoperability, right? So of course in data management, that should be also part of it. Integration data from integrating data from disparate devices, right? Disparate devices and databases or applications require data integration techniques such as data mapping, data transformation, and data synchronization. So we are talking about interoperability of data. We in the above topic we talked about security of data. This is interoperability of data. Then data governance, right? Again, part of it could be a part of security, it could be a part of interoperability as well, because we are talking about standards. Establishing data governance policies and practices, ensuring that IoT data is managed effectively and aligned with organization objectives. Yes, this is one of the points I talked before when coming into EU regulations, and different countries, different regions would have their own regulations as well. So depending on those regulations, on top of normal standards which the world appreciates, right? We talked about that on interoperability as well. Data governance is important. This involves defining data ownership, access control, data quality standards, and data lifecycle management processes. Then I think that is fairly simple and straightforward to understand, right? Data visualization. Presenting IoT data in a meaningful and an easily understandable manner facilitates is decision making and enables stakeholders to derive insights quickly. Data visualization techniques such as dashboard charts and graphs can be used to represent complex IoT data visually. So this is where data goes and interact with the application layer. This is where data goes and interacts with the application layer. So it's basically what we moments ago I was talking about, the same thing. Each layer interacts with the other. Each of these properties or capabilities of an IoT system interacts with each would be there present in each and every layer, right? So here we have data visualization, right? We talked about dashboards, right, and the representation easy to understand, in a easy to understand meaningful way. So that is what data visualization is there for. So data retention and archiving. Defining data retention policies and archiving mechanisms is crucial to manage the growing volume of IoT data. Not all data may be relevant for real-time processing, and achieving all data can be archiving all data can free up storage resources while still allowing historical analysis and compliance requirements. Yes, so there are when coming into IoT, we can think of two ways of storing data. Number one would be archival of data for data analytical purposes, right? Best example, we talked about our weather data, right? We have to compare with our old data sets uh, and give predictions when coming into weather. But there is another kind of archiving involved, which is there are some set of rules and regulations which are there when coming into either banking, security, whatever the situation, depending on the policies of the customer, depending on the policies of the country, depending on the policies of the particular region, or the data we are handling. Right, laws and regulations would also define, right, this is a part of data governance as well, define the minimum period of data that have to be kept with us, right? It could be for government purposes, it could be for security purposes, right, so on and so forth. So those things have to be also counted for. And so archiving of data, why do we need to minimize them? So we know that IoT produces a lot of data in a short period of time because of the amount of devices that are being used in the system. But if you have if you normally use real-time data processing in your IoT system, archival of data sometimes won't be necessary. And when we are saying, okay, we are going to archive data, that means we are going to use data center or cloud resources. If we are to keep on using those resources, we have to maintain and it will be costly for the customer. So in measures taken to for cost reduction and efficient way of handling the costs, right, meaningful and efficient ways of handling the cost, we can actually delete data which is redundant as time goes on, right? So these all are the reasons why archiving of data and not to archive data is there. There can be financial reasons, there can be regulations, right, regulatory reasons, or there can be practical business application or reasons that we need to store data for use in the future. Data monetization, this is also a point that we talked about before. IoT data can be hold value beyond operational use cases. Organizations can explore opportunities to monetize their data by anonymizing and aggregating it to provide insight to external stakeholders, or by collaborating with partners to create new data-driven products or services. Yes, now we are coming into the realm of Facebook, TikTok, Instagram, so on and so forth. Their main business is selling data. So IoT systems, right, IoT by nature is a place where a lot of data is being collected. This is something that we discussed. So that means those data may hold value by the anonymity of that particular data, right? If we are to remove all the metadata, if we are all to remove personal information from that data point, right? For example, if you have logistical data, you are driving from point A to point B, right, we will remove the metadata such as the vehicle number, number plates, owners of owner name of the vehicle, the type of vehicle, so on and so forth. We can calculate the traffic data right, is in real time from point A to B and sell it to other customers who are looking to obtain traffic data. It could be Google Maps, it could be some other company, but that is a possibility. We talked about monetization of weather data. When we can build a IoT company, we can have the entire value chain inside the company itself. So our customer will be buying data from us, not the IoT system. The customer will be buying data from that particular company about the weather, so on and so forth. So this is also one of the topics that we touched upon. IoT devices often collect and process personal and sensitive data. Privacy considerations should be embedded in the design to protect the privacy rights of individuals. Data anonymization, consent management, and privacy enhancing technologies should be employed to safeguard personal information. Again, privacy comes as a part of security itself, right? And of course, privacy comes. It could be separated from security, is because that we need to secure data to help privacy. We need to secure data to help privacy of personal data. So we have talked about this in hospital usage of IoT devices in hospitals, collecting patients' data and so on and so forth. Not only that, in depending on different domains, privacy of data is very important, right? Individual data, personal data, and we talked about how places from country to country also, there are rules and regulations to protect personal data. So how to so when a company is requesting from you to build a IoT system, or requesting you to manage a IoT system, right? Be the service owner or the product owner of the IoT system, behalf of the company, you have to understand that there will be privacy policies on the country that each IoT system is being implemented. On top of that, there will be privacy policies of the company itself, right? Sensitive data would be there, and which is private for the company itself. Therefore, it is important to protect all types of data. Data minimization. Collect and store only the necessary data required to fulfill the intended purpose. Minimization and minimize the collection of personally identifiable information, PII, to reduce the risk of unauthorized access or misuse. Yes, so this is something this is something that is something that is there, that we can be implemented. We can filter out what is the most important data for a person or for the organization, and collect that data. Consent and transparency. Obtain informed consent from individuals before collecting their personal data. Clearly communicate the purposes, types of data collected, and how the data will be used. Provide individuals with transparent information about data processing practices, including any third-party involvement. Yes, when we talk about this point, the first thing that should come to your mind is when installing some kind of a software or registering yourself for some kind of a service, right? Social media or whatever. Right, you will get this privacy notification saying that okay, your data will be collected in such and such a way, and they will be used in such and such a way, right? So this is the same thing applies for IoT, because again we are talking about hardware and software components which will be and will be collecting data. In the perception layer there will be sensors, and those sensors will be definitely collecting data. So and depending on the sensitivity of that particular set of data, we should, especially when coming into personal data, we should be able to provide what kind of data being collected. Um when again we are talking mainly about industrial level of industrial level of application, right? This is some kind of this is how a trust is built between the customer and the product. If you are a IoT engineer, right, you at the end phase of it, not prototyping phase of it, but when in the end phase of building a IoT device plus combining all those IoT devices to build a IoT system, you should be able to tell what data is being collected and where those data is going to be stored and for what reasons those data is going to be used, right? So those documentations should be provided and should adhere to governmental regulations of each region. Data anonymization and pseudonymization. Yes, big words I know, but end of the day it is very simple. It is the both of these terminologies are used for removing personal information, individual information, personal data from the from a particular data set. Implement techniques to anonymize or pseudonymize personal data whenever possible. Anonymization removes personally identifiable information, while pseudonymization replaces identifying information with pseudonyms, making it difficult to link the data to an individual without additional information. Let's look at an example. Let's say you have built a IoT system for a hospital, right? And you will be collecting data from different patients, right? Let's say you are collecting body temperature of each and every patient. In one report, you have to send the individual person's body temperature, right? Each patient's body temperature to their doctor. So the doctor will look into the patient and analyze the data, right? To prescribe medication or to have, increase medication, decrease medication, to keep eye on the patient. So the doctor should able to see these personal information, right? So in that particular scenario, right, the doctor should be able to identify the patient. But this is patient doctor confidentiality in action. That data set cannot be used. Let's say the same data of the hospital is used to see if there's a pandemic situation or people with fever or high temperature is getting admitted more to the hospital or not. By that, do they need to stock up more medication? Do they need to inform authorities of irregular situations, right? you know that there are flu seasons, and when you know that when you are in a class, right, one person coughs, right, give a week the whole class is coughing. So that means it spreads. To predict those things, these information can be collected from the IoT system. But in that particular case, to carry out our predictions, the personal name of the patient or the age of the patient, or any information about the patient itself is not necessary. We can anonymize that data and say patient number 1 temperature this much, patient number 2 temperature this much, so on and so forth. We can give the data, right? Let's say we want to figure out where everybody is getting sick from, right? They want to figure out, okay, where this person is living or where this person is working. Is it a nearby area? They want to see the data pattern of where where most patients are coming from, so they can maybe cordon off that region or check for dengue mosquitoes or things like that, right? For that particular one, pseudonymization is important, right? A particular data set is given, patient number 1 lives in this region, only the region is given, not house information or something like this. So a small data set is given, but without other information, the person who's reading that data cannot find out who is that person. The person who's reading that data, their end goal should be to identify the location where the patients are being created, right? Rest of the data is not matter. So these things are there, these things are mainly there when analyzing data and so on and so forth. So while you are listening to this, you will now understand, right? It is not only the IoT devices that we have to concentrate this matter on. When data structures are being built, right, and giving access to particular sets of data and so on and so forth, we have to build our back-end and front-end infrastructure accordingly. When talking about IoT system, it is not only about the sensors, it's not only about the actuators, it's not only about the devices themselves. It's about the entire ecosystem, which includes networking, which includes data management, data processing, and which includes user interaction and user interfaces. So software, hardware, everything is there on a IoT system. We can go to the next point. Secure data transmission. Encrypted data during transmission. So this is the perception layer. So see, each point applies to each layer. Secure data transmission is a part of security as well, isn't it? If you keep in the transport layer, if security is being managed properly, that means privacy is also managed. So that is why I always say that these things interact with each other. Secure data transmission, encryption data during transmission to prevent unauthorized access and interception. Use secure communication protocols such as SSL and SSL TLS to ensure data confidentiality and integrity, right? So this is something we talked about. I think by going through it, it is understandable for you. Secure data storage. Again, we talked about storage, we talked about security. Both together will give privacy. Protect personal data stored in IoT systems through robust security measures. Implement encryption, access control, and intrusion detection systems to safeguard data from unauthorized access or breaches. So if somebody is here on learning about data management, data structures, anything regarding data, and anybody who's learning about information security, IT security, network security, so on and so forth, right? You will understand that same protocols that you are learning there will be applying for this, right? Because end of the day, IT infrastructure management is a part of IoT infrastructure management, so there will be not much differences. So anybody who has looked into information security in general, network security in general, data security, data management in general, those technical abilities apply here as well. Here we talk about the theoretical part of it, because as you can see, in applied IoT we are talking about everything which involves in a IoT system. So we can't deep dive into every and each topic, it will take forever, right? But trying to give the basic understanding of it. User access controls provide individuals with control over over their personal data, enable users to access, review, and update their data, as well as specify their preferences for data sharing and processing. It's simple and straightforward. Data recycle management. Establish policies and procedures to data retention and deletion. Refine appropriate retention periods for personal data, and ensure that data is securely deleted when no longer necessary. Privacy by design. Incorporate privacy considerations into design and deployment of IoT systems. Implement privacy enhancing technologies, privacy impact assessments, and privacy aware architecture from the outset. Yes, so we talked about when you are a person who is IoT systems architect, IoT service provider, service owner, technology operation manager for some company, the job role will be different from different perspective. But if you know all the topics that are needed to be covered, either when you are designing IoT system, IoT device, IoT system, or the network, maintaining that IoT system as a service provider, or maintaining the network, maintaining the data center, maintaining the software, or the as the customer, you are representing the customer side, you would know what are the information that is needed to be looked into and addressed when as a customer, when you are buying things, buying the product, buying the service as a product, or when you are on the other side of the value chain as a service provider or a device manufacturer, or storage or processing capabilities, back-end cloud service provider, or application designer, where front-end applications are built to interact with the IoT devices, right? Whatever your position, you would know what are the criteria that you must fulfill for either buying or selling a good product, right? So after that, regular privacy assessments conduct periodic privacy assessments to identify and address potential privacy risks in IoT systems, stay up to date with privacy regulations and guidelines to ensure compliance. Third party data sharing in personal data, if personal data is shared with third parties, ensure proper data protection agreements are in place. Assess the privacy practices and security measures of third parties to whom data is disclosed. User education. Educate users about privacy risks and best practices for protecting their personal data in IoT systems. Provide clear instructions and guidance to privacy settings, data sharing options, and privacy related features. Yes, if you are the service provider, if you are providing this as a service, right, we know that IT service providers are there, network service providers are there. It is mostly your responsibility to, right, keep an eye on this third party data sharing, in educating the users, and carrying out regular privacy assessments to see everything is up to standards, right? Not only that, if you are in the customer side, right, if you're in the customer side and if you are the service owner of IoT system, it is your responsibility that all these points are being covered, where regular assessments are done, right? If third parties are getting in data, it's your responsibility to know whom and what is the data which is being shared and why is it necessary, right? Those things are to be managed by you, right? Of course, when you go into the world of into the job market itself, right, in IT infrastructure management or OT infrastructure management, right, where whatever the situation, you will first not be in such a position to look at each and everything in a documentation and in a service agreement and so on and so forth, to understand which data is being shared, which data is being used, right? This is a service operation managers or service product managers, right, IoT system manager, or if you take the or the IoT architects, IoT system architects, so on and so forth, right? These positions would come as you progress as an engineer. But when you progress as an engineer, in back of your head, you should have these points with you so that you would know what to look for, right? This is the reason of this lesson. This is the reason of this subject itself, right? If you are going to start a startup, in the back of your head, right, your new your new product should cover, right, your prototypes and everything would be fine. That as an entrepreneur, it's you can introduce. But when you are creating a startup and when you are giving a new product to the market, you should have the knowledge and you should have addressed these points in your product, because it is very important to give a fight in a competitive market, and we know that the market is growing, so it is important to have a competitive product. Next point is energy efficiency. Many IoT devices are battery powered or have limited energy resources. Designing IoT systems with energy efficiency in mind helps prolong battery life, reduce energy consumption, and improve overall device longevity. Techniques such as low power hardware, optimized communication protocols, and power management strategies should be considered. Yes. So when coming into network optimized network protocols, we know Zigbee, Z-Wave, LoRaWAN, so on and so forth. We have talked about it. Why does, if we stay on this topic for a moment, why is it important, this power management? So number one would be, let's look at the economic terms first, right? End of the day, right, if you are giving a product, if you are having a value chain, it would be it should produce value. It shouldn't, right, the outcome should be more valuable than the money that is being spent on the system. So if the electricity bill comes in sky high because you have implemented 1000 IoT devices on a building, right, to manage the air conditioning, security, door locks, access control, fire alarms, so sprinkler system, cleaning, right, so on and so forth, it would be it will not add value to the building itself. So having energy efficient devices is quite important in this subject, because we are talking about a lot of hardware. Number two, some IoT applications involve remote locations. We talked our favorite example, weather monitoring devices. Sometimes they can be weather monitoring devices implemented inside a forest. If there's a IoT forest fire detection system built, there will be IoT devices inside the forest where there will be no roads or there will be no electricity inside. You will either use satellite communication to send data, but so if that is the case, and if you have to work with a battery for some time, right, in a vast forest area, right, some forests are bigger than Sri Lanka itself, right, in such a situation we can't go replacing batteries every 2 weeks. At least the devices should have the capability to run for 6 months or at least a year without replacing the batteries. So energy efficiency is really important in IoT, because there will be IoT applications. If you take healthcare devices, right, there are pacemakers, right, at least a year it should carry out its functions without fail. Then think about our lecture number 7, right? First example, predictive maintenance, right? You can see that product is manufactured as a ad hoc device to legacy systems. If you look, if you think about that situation, if you think about the logistical example in that, right, that is also a ad hoc device which will be added to the existing legacy system, existing vehicles, right, existing logistical vehicles. So in that case, there will be sometimes there will be no electricity connection to the device itself. It should run on battery. So at least it should be able to run 6 months without changing the battery itself, right? All the sensors, all the communication should be because if every time some kind of a change or maintenance needed to be done by changing the battery or things like that, it will be a nuisance and it will be bad to maintain the value chain itself, right, to maintain the value of the product itself, right? Uh, so these are why we need IoT devices or IoT systems which are energy efficient. This particular point is one of those points which is there in IoT systems itself, right? When we talk about privacy, when we talk about data management, when we talk about reliability, reliance, when we talk about security, right? Those are shared with software developments or software service providing or in the IT infrastructure itself or software infrastructure itself, right? But like scalability and interoperability, which are 2 points concentrating on the perception layer, which is unique to IoT, right? Perception layer is something unique to IoT. Energy efficiency is something unique to perception layer itself, because the network, maintaining the network and running the network itself, right, would be similar to running any cellular or Wi-Fi network, right? But again, we have networks separate for IoT systems, right, which are Zigbee and Z-Wave LoRaWAN. So those are also specific to energy. Those are energy efficient, which is specific to IoT systems, right? Then if we talk about the process layer and the application layer, normally those are already existing layers. Laptops, smartphones, servers, right, access points, those things are already existing layers which consumes electricity and dedicated electricity is given. But rest of it, the perception layer and the network layer of dedicated to IoT, has this unique property of energy efficiency. Scalability, interoperability and energy efficiency. So this is one of the unique points for IoT systems. Device power management. Implement power management techniques at device level to minimize energy consumption. This includes sleep mode, duty cycling, and optimizing sensor sampling rates based on the desired level of data accuracy and frequency, right? Now, when I'm going through these points, you should be able to recall the examples that I was giving before, why we need efficiency in IoT devices, right? Efficient communication protocols. Select communication protocols that are optimized for energy efficiency, such as low power wide area network, LPWAN, technology like LoRaWAN or Sigfox. These protocols are designed to minimize power consumption and enable long-range communication with low data rates. Edge computing. Utilize edge computing capabilities to process data locally on IoT devices or gateways, reducing the need to constant data transmission to the cloud. Performing data processing and analytics at the edge can reduce network traffic and conserve energy. Yes, now think about it. If you build a detection system, forest fire detection system using IoT devices, Yes, in that situation, we have to have IoT devices inside the forest, which is not connected to the grid, which should be run by batteries. In that particular sense, inside the forest, right? We are not don't think about forest in Sri Lanka itself. Uh, think about countries like Australia or the Amazon forest or the forests in Canada, which are 3-4 times bigger than Sri Lanka itself, right? Um, in such situations, these data should be collected and either transmitted. Either the each and every device should be close enough to communicate with each other to build a mesh network using Sigfox or LoRaWAN, or they should communicate with satellites, right? And they should carry out these functions at least for a year, or otherwise in such a large area, changing batteries of each and or servicing each and every device, right? 2-3 times bigger than for us, 2-3 times bigger than Sri Lanka itself, servicing all those devices. It is not a valid solution. It is not a proper solution, right? So therefore, energy efficiency should be prioritized in such IoT systems, right? So all these points lead to those things, for energy efficiency. Data compression and aggregation. Implement data compression and aggregation techniques to reduce. And so in the edge computing situation, think about it. If you can process your data in the device itself, and if you are using satellite technology to communicate, you can send only the needed data, and rest of the data can be dismissed, so that connecting with the satellite would need lot of energy. So only send in the wanted data itself, right? The transmission can be short, so energy can be saved, right? Simple points like that will adapt to the longevity of the batteries themselves. Data compression and aggregation. Implement data compression and aggregation techniques to reduce the amount of data transmitted over the network. By compressing and aggregating data, the overall energy consumption for transmitting data can be significantly reduced. Yes, so these 2 points are for reducing the amount of data that is needed to be transmitted through the network, which will consume energy. Efficient sensor selections. Choose energy efficient sensors that consume minimal power while is still providing accurate and reliable measurements. Opt for sensors with low standby power consumption and fast wake up times to minimize energy usage during idle periods. Dynamic resource allocation. Dynamic allocated systems reduce based on the current demand and workload. By efficiently allocating in computational resources, memory and network bandwidth, energy can be saved by avoiding unnecessary resource utilization. Energy harvesting. Explore the use of energy harvesting technology such as solar panels or kinetic energy harvesters to power IoT devices. Now your head should go to the example we talked about, having a IoT system to detect forest fires. Now you see another solution on top of batteries. Now your head should think about rechargeable batteries and solar power, right? Energy harvesting enables devices to operate without the need of battery replacement or frequent recharging. Enhance overall energy efficiency. System optimization. Continuously optimize the IoT system architecture, software algorithms and protocols to reduce energy consumption. This includes optimizing routing algorithms, data aggregation strategies, and power management schemes to ensure efficient operation. So again, in service management level, this will come, right? It's a development life cycle. On top of, if you take agile management and those things, right, you develop a software, you publish the software, people use it, we will get sometimes we will get issues of the software, saying that some things are wrong, so we will check, we will update the software, we will republish a new version, right, as an update. Then again, there will be some faults, or after some time we want to add a new feature in, right, we then so it's a whole cycle, it will go on and on and on. Similar to that, in IoT systems, this will continue as well. Predictive analytics. Utilize predictive analytics to optimize energy usage by analyzing historical data and patterns. Predictive algorithms can anticipate energy requirements and adjust device operations accordingly. Optimizing energy consumption. Yes. So this could be an ironic point, because IoT devices can be used for predictive analytics on other things. Here we are talking about using predictive analytics to analyze the IoT system, IoT devices themselves. Life cycle consideration. Consider the entire life cycle of IoT devices, including manufacturing, development, use, and disposal. Implement energy efficient manufacturing processes, recyclable materials, and proper disposal mechanisms to minimize the environmental impact. Yes, this is something extra from energy efficiency. There are some rules and regulations and trends that are going on to for reducing environmental impact. On top of that, if we optimize the method that we are building the price, if we are using this much amount of energy and resources to build a device, and if we can build the same device with less energy, less manpower, less work hours, right, the price of the device can be also be reduced, so then the device can be competitive in the market itself, right? So overall in the value chain system, that will also help, right? Because end of the day, whether you like it or not, when you have a startup, right, when you have IoT product or IoT system as a product, or if you go to a job role where you are a IoT engineer, or you are a data center engineer, or you are end of the day, it's the value that you create, because we live in a capitalistic world. So to be successful, you should always keep in mind how to be productive and how to add value to the value chain itself. If you want to have a productive IoT product, if you want to buy a productive or value adding IoT product, the value it gives have to exceed the expenditure on maintaining that IoT system, not only buying, maintaining. So that is a financial decision, end of the day, right? All these points end of the day leads to a financial decision. So yes, it is exciting when you have a new entrepreneurial idea and you make a new hardware device, when you when you make that hardware device, right, then you should after making that hardware IoT device, right? After making that IoT device, you should use applied IoT to make it a complete compatible device to the market. I hope that makes sense to you. As an entrepreneur or a startup, you will have an idea, you will build a IoT device, right, using your IoT knowledge, using your programming knowledge. Then you should think about applied IoT and think about, okay, what is the data which is going to be produced by this? Are we going to collect private data, or are we not going to collect private data? Can this be hacked? Are the data secure? Is it energy efficient? Right? Where are we going to store the data? Are we going to give a mobile application to the customer with this IoT device so they can interact with the IoT device? So those things have to be thought of, and that thought process is what we are learning here now. Okay, right. Real time and low latency is our next topic. Real time and low latency. Some IoT applications require real time or near real time data processing and low latency. Designing IoT systems with low latency communication, edge computing capabilities, and real time analytics enables timely decision making and responsiveness. Yes, so this is something that we already know of. This is something that we already talked about when we are talking about IoT devices for health monitoring, when we were talking about IoT devices for when we were talking about IoT devices for weather monitoring, when we were talking about IoT devices to control fires, right, inside buildings, right? What will be the smart solution, right? The main point we stressed out is because this is creating real time situational awareness. This is sending out notification in real time. The response time will be shortened. Therefore, quick actions will lead to better results. So in IoT, right, like the last topic, real time data processing, real low latency or real time data presentation to the person who needs it, right, to the process who needs it, is important and is a good property of IoT. So if you so I'm not going to take some time on this particular topic, right, about talking about examples. We know plenty of examples by now, right? We have gone through multiple examples which require real time data to as the solution of or the output of IoT devices. So we will talk about the several sub points when coming into real time data or low latency data processing. Edge computing. Employ edge computing techniques to perform data processing, analytics, and decision making at the edge of the network, closer to the data source, by reducing the distance and latency associated with transmitting data to the cloud. Edge computing enable faster response time and real-time capabilities. Yes, now by now I think you know what is edge computing, and you uh, may have a understanding of what is edge computing. Basically, the system or the processing chips that are there to process data inside the IoT device itself. So rather than sending the entire raw data to the cloud, sending processed data, right, could then the amount of data respect to the raw data will be less. On top of that, it will be processed so that the latency of again collecting that data without being corrupted, right? Because raw data, if it is a large quantity, it will take time to transfer, so those transfer rates will go, timing will go down, so that it will be low latency, right? Low latency communication protocols. Choose communication protocols that offer low latency and real time capabilities, such as MQTT, message queuing, telemetry transport, or co-app constraint application protocol. These protocols are designed to minimize network overhead and support efficient message delivery with low latency. Yes, we are now talking about the transport layer. In the transport layer itself, we are talking about general networking. So I don't think we need to think about anything. We don't need to think about more or about networking. Anybody who has a idea about networking, who has learned networking, knows these protocols are there to reduce latency, right? On top of that, in the transport layer, we have the next option, high speed networks. Utilizing high speed networks such as 5G, Wi-Fi 6, or dedicated industrial networks to ensure low latency and fast data transmission. These networks provide higher bandwidth and low latency, enabling real time communication and reducing delay in data transmission. Yes, if we are to talk about um, communication uh, on real time, right? Uh, let's take a example, not an obvious example. Let's take something like a manufacturing plant, right? There will be robotic arms in a manufacturing plant working together. These robotic arms would be also networked between each other to work in conjunction with each other. So they will be sharing data, they will be sharing sensor data, we will be sharing in uh, um, actuator commands between them. In a factory, to those things to work smoothly, right, it would be better to use the latest technology with the highest bandwidth, so those robotic arms can communicate in real time. If there will be delays, that means the manufacturing line would be delayed. So then if that would be the case, the IoT devices will not be giving productivity in general, right? If productivity is not there, there won't be any value created. So then if there's no value created, there is no use of that IoT system, right? um, Therefore, bandwidth is something very important. That is, if you take the obvious topic of medical industry and real-time monitoring of a patient, right? Bandwidth, latency, these are things I think which which goes without saying, right? Uh, we should know, we should have the lowest latency when coming into delivering those real time results from the patient to the doctor or the nurses who are attending. Next option, now we are getting into the process layer, right? On top of process layer, we can say we are this part will be also there in edge computing in the perception layer as well. Data compression and prioritization. Implement data compression techniques to reduce the size of data transmitted over the network, thereby reducing latency. Additionally, prioritizing critical data to ensure it is processed and transmitted with minimal delay, while non-critical data can be processed with low priority to avoid congestion. Yes, so now we are there in the programming level of perception layer and processing layer, right? If data to be transferred from processing layer back to the perception layer with commands for actuators, or if the processing layer to send digital signals to the application layer, right? These compression techniques or prioritization of um, data can be taken into place, right? On on top um, on top of that, we learned about edge computing. We talked about this point in the very top, right? When the IoT device or the perception layer is going to talk to the process layer, right? Also data compression can be done, right? Prioritization of data can be also done according to the system. For example, um, you may have a security camera system which would occupy the network at all times, right? Data will be sent and it will be processed. There will be a uh, access control IoT system in place, right? There will be smart lighting in place, so everything will be on the same network. If that would be the case, if a smoke alarm goes off, that particular data will be prioritized on top of every other data point that will be there, right? We can make our network in such a way that the packets which are generated from data packets which are being generated from smoke alarms would have more priority in the network. On top of it, when handling data also we can give more priority, so there will be low latency in sending out the notifications or the message to the application layer, where the user can see there is a fire, take quick action, right? Points like that is important. Again, these points should be considered depending on your IoT product, right? If you are to make an entire building, let's say a 50-story building, a 50-story office building, a smart building with energy efficiency and automation in mind, I think these points also should be considered, right? A good product, a better product would have these properties as well. Real-time analytics and processing. Utilizing real-time analytics and processing capabilities to analyze data as it is generated. This enables immediate insight and action based on real-time data streams, reducing processing delays and enabling rapid decision making. Yes. So similar to the example we were talking about, then prioritizing the data points, real-time data processing could also help with the same thing. Low latency hardware and sensors. Select hardware components and sensors that offer low latency capabilities. For example, choose sensors with faster response time and low data transmission latency to ensure real-time data capture and accurate measurements. Yes, one of the things that we talk about in the IoT when designing an IoT device, when selecting your sensors and actuators, we look at the data sheet. So the data sheet will give the relevant information when coming into low latency hardware and sensors, right? Depending on our requirement, we can select the best product with low latency. Efficient algorithm design, optimizing algorithms and software designed for low latency and real-time processing. Use efficient algorithms, data structures, and parallel processing techniques to minimize processing time and enable rapid data analysis. Predictive analytics, utilize predictive analytics to anticipate future events based on historical data, reducing the need for real-time processing and enabling in productive decision making. By leveraging productive models, IoT systems can respond in advance to potential issues, reducing latencies in critical situations. So by when we are talking about this, right, things like for example, right, we productive maintenance IoT devices, right, which have which can predict maintenance periods and so on and so forth should come to your mind. Another example would be, right, our weather systems. If we know, okay, the heat goes above this much, forest fires may occur. So then governmental agencies that control the forests, right, can take measures to mitigate or stop forest fires from taking place, maybe by a maybe by clearing dead leaves from the ground which can easily catch fire, informing people who are going on hikes not to smoke or use fire in campsites, so there will be no artificially igniting any woodlands, so on and so forth. So in that case, right, real-time monitoring can have a rest, because predictive analytics have taken over, right? And so in before real-time IoT how to say it, before real-time IoT data collection is needed, by predictive analytics, right, the system or the users of that system can take action, so that events that would take over the IoT existing IoT network, right, needing to prioritize, needing to dedicate more resources to a single event, should be minimized. And by predictive analytics, of course, same scenario can be taken to maintaining the IoT system as well. End of the day, what this will do is it will reduce the amount of real-time processes that is needed to be carried out, reducing the stress on the IoT system itself. Continuous monitoring and feedback, implement continuous monitoring and feedback mechanisms to measure systems latencies and performances. By monitoring latency metrics in real time, system bottlenecks and performances issues can be identified and addressed promptly. So this is, yes, a part of similar to IT service management. We talked about operational technology service management, or OTSM, or IoT service management. So this is the we use managing techniques such as ITIL to have managing tools and managing methods or protocols or processes, so that continuous monitoring and feedback cycles would take place. Hardware acceleration, employ hardware acceleration techniques such as specialized processors, field programmable gate arrays, FPGAs. Yes, so FPGAs are very important if you are going to go in a research path, towards IoT, right? IoT, mechatronics, um, mechanical engineering section. There will be a part of automation. Those parts, right? FPGA is would be a programmable gateway arrays are part of it. GPUs, so that is something that is needed to be. So we are still talking about Arduino and Raspberry Pi, but today the constraint of M2M, we talked about machine to machine, and IoT, OT, basically mechatronics itself, right? Electronics and mechanical industries meet to each other. So we have a subject now called mechatronics. Similarly, right, M2M communication would be a part of mechanical engineering, but today it comes more towards electronics, right? And electronics have moved towards more towards a little bit of hardware. So everything is a mixture. So that is one of the, speaking of M2M devices, that is one of the points that I try to highlight again and again, because if you are to study IoT, then your field of interest should be there on IoT, mechatronics, electronics, subjects like that as well, right? So we will that's a tangent outside of the content that we were talking about. So field programmable gateway arrays or graphic processing units to offload computational tasks to improve real-time processing capabilities. Yes, so in cloud systems, of course, you have the ability to increase the processors which is being used, and so on and so forth, right? If you have your own devices, IoT devices, IoT gateways which are processing these things, you can select or overclock them, right? But if overclocking seems harmful for the hardware longevity, it is better to have then predictive analytics. User-centric design. IoT systems should be designed with the end user in mind. User interfaces and interactions should be intuitive, user-friendly, and accessible. Design considerations should address usability, user experience, and user acceptance to ensure adoption and satisfaction. Yes, so this is something which is there in software design process as well, right? If you take the hardware devices, it should be easy to interact with them and to understand buttons or touch screens or any other form of interaction, any actuator which is used to interact with the IoT device should be clearly marked and clearly observable and easy to use for the user. Then of course, when you take the application layer, everything should be easier and understandable for the user, right? If you think about products that are there on Amazon, for smart homes, right? They will be much, the instructions are clear, the instructions are maybe maximum 10 steps to from switching on the device to integrating it to your smart home, maybe with Alexa and so on and so forth. So that is also something that when coming to any IT product, user-centric design is very important. If you know about now about cloud computing and especially when coming into cloud computing and Windows servers, right? It's not like past, right? Especially when coming into cloud computing, it is a graphical user interface rather than, and remembering typing your code in, and right, so the interaction is more user friendly. Even in in process layer it has become more friendlier. And yes, user interaction happens in the perception layer and the application layer mainly, right? And we should make sure that the um, it's a user-centric design. On top of it, we are talking about hardware devices, right? Some of the hardware devices may have actuators which moves around, right? So user safety is something also that is needed to be considered. So user research, conduct thorough user research to gain insight to user behavior, goals, uh, pain points and preferences. This includes methods such as interview surveys and usability testing. Understanding the needs and expectations of user is crucial for designing a system that meets their requirement. Yes, if you have a problem or if you want to automate a process, right, first thing you do is talk to the customer or the user, and you try to understand what is your problem or what is the existing process. Then you give solutions how you can automate, right? So this is basically similar to similar in software designing as well. user um, User personas, create user personas that represent different user groups and their characteristics. Personas help in visualizing and empathizing with user, guiding design decisions and ensuring in the system cater to diverse user needs. Yes, so why do we presume that different users may have different personas? We talk about example where we implement IoT devices in a clothing manufacturing company, right? So if you take the people who are working there, their knowledge, their set of skills and their knowledge is mostly based on clothing manufacturing, not technology. So we should understand the level of knowledge they have with technology, because their normal interactions will be with their smartphones or maybe with a laptop, right? Anything beyond that, using in a command line prompt to interact with your device will not work. So that's why depending, we should understand the user, right, and their technical capabilities, right? So we should make things easier for them by understanding their persona, right? If you take the support engineer who will be there on that site, cloth manufacturing site, his persona and the applications or the settings or the device, the privileges or the admin role that he would be playing to maintain the system is different. His interaction with the IoT system would be different in respect to a user who is on the clothes manufacturing line. So things like that, depending on the persona, we have to give the ability to work with the IoT system. User experience, UX design, employ UX design principles to create intuitive and seamless experiences for users. This involves design clear and simple user interfaces, minimize cognitive load, and ensure consistency and easy to use throughout the system. Yes, when I think you have learned about UX UI designs, right? And these principles in the application layer applies to IoT as well, right? It would be much easier if the user can understand what is being displayed, right? Rather than giving a set of whole numbers, putting it into a chart form may be visually better for the user to understand things like that in a control panel, right? So on and so forth, we can design a better UX. I'm not going to dwell a lot of time in this because these are properties which is being shared throughout the IT environment. If you talk about networking, um, if you talk about network products, if you talk about cloud products, especially if you talk about the application or the front end, right? These are common features which is being shared. It is not something which is restricted to IoT itself. Context and awareness. Design the system to be context aware, considering the physical and environmental factors in which the IoT device will be used. Account for factors such as location, time, use activity, and preferences to provide personalized and relevant experiences. Again, then that means language, time. If you are in Sri Lanka, right, you have to have 5:30, 5.5 hours in front of plus 5.5 hours GMT. If you are in another country, it should uh, basically display the correct time. Then it should, if the languages are different, it should change the languages accordingly. Simple things like that to help the user interaction. User interface, UI design. Pay attention to the visual design of the user interface, considering factors such as color schemes, topography, iconography, and layouts. Design visually appealing interface that are easy to navigate and understand. Yes, so basically same with UX. We are here with UI, right? I don't think I need to explain from top to bottom that part, because these are simple and commonly described points when coming into uh, user preferences, or uh, users interacting with a software or a particular system. Ease of setup and configuration. Simply the setup and configuration process for users, reducing the complexity of connecting and configuring IoT devices. Provide clear instructions, automated setup procedures, and intuitive user interfaces to ensure a smooth onboarding experience. Yes, we talked about the example of Alexa and Amazon products that can interact with Alexa, right? So when coming to smart homes, it is much better if the person who's buying it, the individual, even though they don't have much technical experience, would be able to interact with the device and register the device through application or something, and make it functional. If you are a service provider, it is better to communicate with the device manufacturer, who is designing and manufacturing the IoT devices, so that the needed information will be there for the service providing party, or the service providing engineers to work with. And if difficulties can be communicated to the device provider, right, the device provider surely should address those and make life easier for the implementation engineers of the IoT system. So when coming into complicated systems, so implementation and maintenance would be easier, and with less technical knowledge, these things can be maintained and established. uh, so the weight of designing and manufacturing a device would be on the R&D section rather than the service providing section of the value chain. Personalization and customization allow users to personalize and customize their IoT experience according to their preferences. This can include options, settings, preferences, creating user profiles, and tailoring the system to their specific needs. Yes. So on top of that point, I will say that if you are thinking about commercial use, right, in a company and large scale use, right, so depending on the different company and their requirements, we have to definitely tailor made the IoT system, configure the IoT system accordingly. Feedback and support, incorporate mechanisms for users to provide feedback and seek support. This can include features such as in-app feedback forms, customer support channels, and online communities. Actively listening to user feedback and addressing this concern to continuously improve the system. Yes, we talked about service providing, right? In large scale or small scale, feedback is important, right? So we can refine the system. Accessibility, ensure the IoT system is accessible to users with diverse abilities and disabilities. Consider guidelines for accessibility, such as providing alternative text for images, supporting in screen readers, and accommodate different interaction methods. So this would be an accessibility. It would be important for people, especially smart home devices, which are catering for patients, people with disabilities. Health monitoring devices comes into mind, as well as, let's say, you design IoT devices for elders home, right, to make their life easier. And so accessibility is something that is needed to be prioritized on such a example. Privacy and security, prioritizing user privacy and security throughout the design process incorporates privacy settings, clear consent mechanisms, and robust security measures to protect user data and build trust. Yes, we talked about this topic a couple of times throughout. As I told you, these all interact with each other. That's why this is there. Continuous integration, embrace an interactive design approach, continuous gathering feedback and integrating on the system based on user insights. Regularly evaluate and refine user experience to enhance usability and address evolving user needs. Yes, so that is also a point that is there for software, but I think the software section is being covered, so we can think about the hardware section or the perception layer. In the perception layer, sometimes users might say, oh, these sensors are not working enough, or these sensors are not reaching far enough, right? Let's say these sensors which are there to see motion, right, does not only cover, let's say, a radius of 2 meters. They say, oh, that is not enough, we need at least 5 meters to be covered. So when the customer says this is our requirement, we should be able to upgrade the sensors through the perception layer, or configure it through by altering hardware performances, right? So things like that. This will come end to all the main points of IoT, right? We went through the four layers, right? Then we talked about each and every layer. Then we talked about main design principles and its compatibilities of IoT systems. We talked about 9 points. So these 9 points apply to the entire architecture, right? Building this architecture would create the IoT value chain, right? You can place yourself in any point as a service delivery manager, as an engineer, project manager, IoT systems architect, so on and so forth, right? Entrepreneur, a startup, so on and so on, right? You can place yourself on the value chain as necessary. These are the main points of applied IoT. We started from IoT, what's a IoT device. We came along the path and we understood what is the what are IoT applications, what will IoT do, so on and so on. We then took an introduction to what is applied IoT. Then we talked about how M2M and how the M2M, OT, IIoT concepts, right? These are similar things in the nature right now with the current technology. It's not much different. And we then went into talking about the market perspective, which is overall it's positive. Then we talked about the value chains which are there, right? And we talked about how um, depending on your job role, depending on your either a startup or your business or so on and so on, how can there are different roles in the value chain itself, right? Then we talked about the entire architecture which the value chain builds, right? This architecture, uh, so the value chain is there for this architecture. When implementing this architecture, this is the architecture for IoT system. So when implementing this architecture, uh, entire IoT value chain is being created, right? Then after that we talked about the properties. We can say they are the properties that should be commonly there when designing a IoT device, IoT system, or anything on the architect IoT system architecture, which means these things should be there in each and every position of the value chain also, right? Your value chain will have value when you have main design principles and its capabilities on the either device network, right, back end, front end, in the processing layer, so on and so forth. So I think that covers most of the main points for applied IoT, and I wish everyone the best of luck, right? Take care, everyone.